Hello and welcome back to this video series. This is working with determinants. We're going to talk about Cramer's rule, which is a way that we take a 2x2 determinant or a 3x3 determinant or possibly larger and use it to solve a system of equations. So here's how it works. Cramer's rule for a 2x2 matrix works like this. We're going to have two equations with two unknowns, so typically we have an x and a y here. There's a constant term here, a1 and b1. There's a coefficient a, coefficient b, constant c, and a similar one for the next equation. So of course if we graph this, we want to know where the two linear equation lines intersect, and that ordered pair is the solution to the system. Well, what we need to do is take this two unknown system of equations and create a coefficient matrix and a constant matrix. And Cramer's rule is going to combine that and so that we can solve the system. Here's what that means. Coefficient matrix means that we just take the x and y coefficients here and write them down in a 2x2 matrix. So we have a1, b1, a2, b2. Whatever those coefficients are, we just make a 2x2 matrix out of it. The constant matrix is, of course, pretty simple. It's going to be C1 and C2. Now, we're going to use this to actually do some substituting here, and you'll see how that works in just a second. So, Cramer's rule says that first we need to determine the determinant of the coefficients. So usually in most textbooks that's considered a capital D. Alright, so we just take the 2x2 determinant of those coefficients. Alright, that's the easiest first step. Next, I need to find the determinant of the x's. Okay, now this is kind of interesting. If we're talking about the x's, we're going to use the constant matrix numbers here and substitute it in place of the x coefficients. Okay? So here's what that looks like. They substitute in for the x coefficients, and the y coefficients here stay the same. So notice the substitution here. Then we do our cross multiplication and figure out the determinant value. So to solve for y, the x coefficients stay the same, but the y coefficients get substituted by the constants, as you can see here. So to get our solution for x and y, x is going to be the x determinant divided by the coefficient determinant. And y, the value of y in the solution, is going to be the y determinant divided by the coefficient determinant. Alright, so it's a simple ratio or fraction when we're done, and it's kind of a tricky process to make sure the signs are correct, but we need one example here to kind of mix this up. Let's look at number 7 here. We have negative 2x, negative 3y equals negative 18, and we have the other linear equation, x plus 5y equals 16. Now first of all, we're going to take a look at this part here, and we're going to have the coefficient matrix. So that's going to be negative 2, positive 1, negative 3, positive 5. Okay? Let's go ahead and figure out the determinant there. So cross multiply, that'd be negative 10 minus negative 3, which would have to be, change the sign there, that would have to be a negative 7. Alright, we'll use that in our final step. But what we have to do is we have to figure out the determinant of the x's. Alright? In other words, what we're going to do, and I'll go ahead and write it in determinant form, so straight lines here instead of brackets. So what we're going to do is, instead of the x coefficients here, we're going to substitute them with the constants. So negative 18 and positive 16. And the y coefficients stay the same. Negative 3, positive 5. So that's going to look like that. And let's go ahead and cross multiply. So negative 18 times 5 is negative 90. And 16 times negative 3, change the sign, be 48. Okay? And that answer, of course, is negative 42. All right, let's find the y determinant. All right, remember now that is going to be the x coefficients stay the same, negative 2, positive 1, but the y coefficients get substituted for the constant matrix numbers. So negative 18, positive 16. Now we're going to multiply here. Negative 2 times 16 is negative 32. 1 times negative 18 is negative 18. But remember, we have to change the sign. And so our y determinant is negative 14. All right, to actually get our x value, we're going to take the determinant of the x value and divide it by the determinant, which is negative 42 divided by negative 7, and that will be positive 6. The y value is going to be the y determinant divided by the coefficient determinant, which is negative 14 divided by negative 7, which of course is positive 2. All right, now when we solve a system of equations like this, you know that the answer is sometimes expressed as an ordered pair. So, what's the x solution? Positive 6. What's the y solution? Positive 2. That's where the two lines would intersect on a graph. All right, come back to the next video where I'm going to have you solve 3 examples of 2x2 systems using Cramer's rule. Thanks for watching.